Good morning friends. In today's lecture we learn about the projection of line. We draw the front view and top view of the line for the given different condition. In projection of point we draw the front view and top view of the point for the different condition. Okay, similarly here we draw the front view and top view of the line for the given different condition, but the difference is point is dimensionless and here line is one dimension. Okay, so the length of the line is required to draw the front view and top view. Okay, so and understand different condition, here we learn the 6 different cases. Okay, so before starting the projection of line, first we revise the main topics that we learn in projection of point. Projection of point, we learn that for the representing the point we have two conditions for the point, one with respect to HP and one with respect to VP. Okay, with respect to HP, either the point is above HP or below HP. Okay, and with respect to VP, either the point is in front of VP or behind VP. Okay, if the point is above HP, then we draw the point above the reference line, and if the point is below HP, then we draw the point below the reference line. If the point is in front of VP, then we draw the point below the reference line, and if the point is behind vertical plane, then we draw the point above the reference line. Okay, and if the point is on HP or VP, we represent that point on reference line. Okay, and one more important point is when we representing the front view and top view of the point, its front view and top view are on the same vertical line. Okay, because student make mistakes at here. Okay, for example, here if I take one example that point A is 10 mm above HP and 15 mm behind VP, then first we draw the reference line. Okay, and 10 mm above HP, so we take the distance 10 mm above and mark the point A dash. Okay, and for 15 mm behind VP, we take the 15 mm on same line at here. Okay, and measure 15 mm and mark the point A. Okay, so this is the right way to representing the front view and top view of the point. Okay, now we come to the today's topic, projection of line. Okay, we in this topic we learn 6 different cases to understand the different condition for the line. Okay, first case is line is perpendicular to HP and parallel to VP. Okay, we know about the two principal profile plane, horizontal plane and vertical plane. Okay, the first case is line is perpendicular to the horizontal plane and parallel to vertical plane. Second, line is perpendicular to vertical plane and parallel to horizontal plane. Then line is parallel to both HP and VP. Then the line inclined to HP and parallel to VP. Fifth, line inclined to VP and parallel to HP. Sixth one, line inclined to both the HP and VP. Okay, so let's see the all 6 cases one by one. Okay, let's start with the first case. First case is line perpendicular to HP and parallel to VP. Okay, here in this case, this line AB is perpendicular to the horizontal plane and parallel to vertical plane. Parallel to VP means point A and B have same distance from the vertical plane. Okay, now for drawing the front view of this line, if I see from this side, okay, then its projection, I get its projection on vertical plane at here. Okay, so I get the front view on vertical plane. For front view I give the name A dash B dash. Okay, and if I seen from the top, okay, then its top view, its projection we get on the horizontal plane at here. Okay, so I get its top view. Okay, and give the name A B. Okay, here AB line is vertical. Okay, the AB line is perpendicular to HP, so if we seen from the top, it look as a point. A and B look at the same point. Okay, so here we get only one point, A and B at the same point. This is the pictorial presentation. Now draw the orthographic presentation. I just simply rotate horizontal plane 90 degree in clockwise direction. Okay, so I get the horizontal plane exactly below the vertical plane. Similarly in this way. Okay, so here I first mark the point A. For example, here this distance point A is x mm above the HP and y mm in front of VP. Okay, so here from here reference line I measure x mm above the HP and mark the point E dash. Okay, and for point A I measure point A is y mm in front of VP. Okay, so from here I take the distance y mm and mark this distance is x mm above and y mm and mark the point AB. Okay, A and B are the same. Okay, now getting the B dash point, I simply take this distance. This is the true length of the line. Okay, so from here I measure the distance and mark the point B dash at here. Okay, so in this way I draw the front view and top view for the line AB, which is perpendicular to HP and parallel to VP. Okay, let's see the second case. Second case is line is perpendicular to VP and parallel to HP. Okay, so if I see from this side, I get its projection on vertical plane at here. Okay, so at here I get its front view and I give the name A dash B dash. Okay, and if I see from the top, okay, then I get the projection on horizontal plane at here. Okay, I give the name A at here and B at here. Okay, so I get my top view for the line AB. Okay, now draw the orthographic presentation. Here, for example, point A is x mm above the HP and y mm in front of VP. Okay, so here from reference line I measure the x mm distance and mark the point at here. Okay, this give me the front view A dash B dash. Okay, front view of the line AB. Okay, now draw the top view. I measure the distance y mm at here because point is y mm in front of VP y mm and mark the point, so I get my point A at here. Okay, now taking the true length at here, I mark the point B. Okay, so in this way I draw the front view and top view for the line AB, which is perpendicular to VP and parallel to HP. Okay, this is my top view and this one is front view. In this case this is the front view and this one is top view. Okay, so the conclusion of these two cases is we get the true length of the line on the plane which is parallel to the line. Okay, here in first case line AB is parallel to VP, so we get this true length on the vertical plane. Okay, true length means the actual length of line. Okay, we get the exit length of AB on the vertical plane because line is parallel to VP. Okay, and second point is if the line is perpendicular to the any plane, then we get the simple 1 point for this line. For example, here line is perpendicular to HP, so we get only 1 point on HP. Okay, and here line is perpendicular to VP, so we get 1 point for line AB on vertical plane. Okay, so we get the true length of the line on the plane which is parallel to the line. Okay, and we get the point for the line on the plane which is perpendicular to the line. Okay, so this is the conclusion of these two cases. Okay, let's see another case. Okay, in the third case is line is parallel to both HP and VP. Okay, so we get the true length on HP as well as VP because line is parallel to HP as well as VP. Okay, so for here I just take the projection on a horizontal plane to get its top view. Okay, so here I get its top view and give the name A B. Okay, this is true length because line is parallel to HP. Okay, and here I take its projection on vertical plane to draw its front view. Okay, so here I get front view A dash B dash is also true length because line is parallel to VP also. Okay, now to drawing its orthographic presentation, I simply measure distance here x mm, point A is x mm above the HP and y mm in front of it. Okay, so from here I measure the distance x mm and mark the point A dash, and here I measure the distance y mm and mark the point small a. Okay, now I just simply draw here line is equal to true length is equal to true length, and mark the point a dash b dash. Similarly here draw the line and mark the point a b. Okay, here you see that the point a dash and a on same vertical line. Similarly point b and b dash on same vertical line. Okay, now let's say the fourth case line is inclined to HP and parallel to VP. Okay, here line is inclined to HP means it's make an angle at here, and when the line makes the angle with HP, it's denoted by angle theta. Okay, so here line AB makes an angle theta with horizontal plane. Okay, and the line AB is parallel to VP means point A and B have same distance from the vertical plane. Okay, so now for drawing its front view, I take the projection on vertical plane at here and at here. Okay, so I get its front view at here. I give the name A dash B dash. Okay, here angle is theta. Okay, and for getting top view, I take the projection on horizontal plane at here and at here. Okay, so here I get its top view. I give the name A B. Okay, here you see that the line is parallel to vertical plane, so we get its true length on vertical plane. Okay, second important point is here line is makes an angle with HP. Okay, but we seen that this angle theta when we see the line from front view. Okay, so we represent this angle theta on vertical plane. Here line makes an angle with HP, but we represent it on vertical plane. Okay, so this point is important. Note down that the line is making angle with HP, but we represented it on vertical plane. Okay, because we seen this angle from the front. For drawing its orthographic presentation, I take the distance x mm and mark the point A dash. Okay, now here I take that angle is equal to theta and length is equal to true length. I draw its front view at here. A dash, this length is true length and angle is equal to theta. This angle is equal to theta. Okay, so I get my front view A dash B dash. Okay, now for drawing the top view, I take the distance y mm at here because line is y mm in front of VP. Okay, and for getting its top view, here I mark the point A, projection of A. Okay, and here I draw one horizontal line. Okay, and I take the projection of B dash point at here, which intersect the locus of line A at here. So I give the name B at here. Okay, this one is locus of line A. Locus means set of point which have same distance from the reference line. Okay, here on this line I take the point A anywhere, it's have a same distance with the reference line. Okay, so from here B dash point I take the projection up to this line, locus of A. Okay, so I get the projection of point B dash on this line B. Okay, so in this way I draw its top view AB. Here the length AB is less than the true length because line is inclined to HP. Okay, so when we see the line from the top, its length is reduced due to the inclination. Okay, so here length AB is reduced than the true length. Okay, here we have in front view A dash B dash is the same, is equal to true length because line is parallel to vertical plane. Okay, let's see the another cases. Okay, in this case, fifth case, line is inclined to VP and parallel to HP. Okay, so here line makes an angle at here. Okay, this angle, when the line makes an angle with VP, it represent by phi. Okay, so here the line makes an angle phi with vertical plane and is parallel to horizontal plane. Okay, so for drawing its front view, I take projection of line AB on vertical plane at here. Okay, so I get its front view A dash at here and B dash at here. Okay, and to getting its top view, I take the projection on horizontal plane. Okay, so I get A point at here and B point at here. Okay, so at here I get its top view. Here this angle is phi. Okay, which make the line with vertical plane. Now for drawing its orthographic presentation, from here I take the distance x mm above and mark the point A dash. Okay, now from point A dash I draw the locus. Okay, this is the locus of point A dash. Okay, now from reference line I measure the distance y because line is y in front of VP. Okay, now here I get my point A. Now from here I take the angle phi and draw the line, and length of this line is equal to true length. This angle is phi and length is equal to true length, so here I get my point B. Okay, now from point B I take the projection, okay, up to locus of A dash. Okay, so when this projection intersect the locus of A dash, I get my point B dash. Okay, so this is my front view and this is my top view. Okay, here we note down that here line is makes an angle phi with the vertical plane. Okay, but we seen this angle when we seen the line from the top. Okay, so line makes an angle with vertical plane, but we represent this angle on horizontal plane. Okay, so in early case when line makes an angle with HP, angle is theta. Okay, we represent it on vertical plane. Here line makes an angle with vertical plane, phi angle. Okay, but we represent this on horizontal plane. Okay, so note down this. Okay, and here we get the true length on the plane which is parallel to line. Okay, now let's see the last case, which is line inclined to both HP and VP. Okay, in this case line is inclined to HP as well as VP. Okay, line makes an angle theta with HP and makes an angle phi with vertical plane. Okay, so here line is not parallel to any plane, so we not get the true length on any plane. Okay, so let's draw its front view and top view. For drawing the front view I take the projection on vertical plane. Okay, so I get the 2 point A dash and B dash. Okay, and for drawing the top view I take the projection on horizontal plane, so I get the point A and B at here. So here this one is my top view and this one is front view. Okay, here this angle is not theta, but this angle is apparent angle alpha and this angle is apparent angle beta. Because line is not parallel to VP, so this angle is not equal to the theta. Okay, this is the apparent angle alpha and this one is apparent angle beta. Okay, here this one A dash and B dash is front view and AB is a top view for the line AB. Okay, so if I draw its orthographic presentation, I take x distance at here and y distance at here, so I get here A dash point. Okay, so from A dash point I take the angle alpha and mark the point B dash. This angle is alpha. Okay, and from here I get the point A, and from A point I take the angle beta. So here and length is equal to top view length. Okay, so here I get the point B. Okay, here you see that the B dash and B point are on the same vertical line. Okay. Okay, for better understanding of last case when the line is makes an angle with HP and VP, let's see one problem. Okay, problem is given that the line AB is 70 mm long. Okay, so here the true length of the line is equal to 70 mm. Line AB is 70 mm long. It makes an angle 45 degree with the HP. So it makes an angle theta is equal to 45 degree with HP and 30 degree with the VP. Okay, so angle phi is equal to 30 degree. Draw its projection when the point A is 10 mm above HP and 15 mm in front of VP. Okay, now better understanding of this problem. First I divide this problem in two parts. Okay, in first part line is makes an angle 45 degree with HP and parallel to VP. Okay, and in second case line makes an angle phi is equal to 30 degree with vertical plane and parallel to HP. Okay, that we already learned. Okay, in earlier two cases. Okay, let's first draw for the first case. In first case, given that the line makes an angle theta 45 with the HP. So first I mark the point E dash and A. Here the point A is 10 mm above HP. So from here reference line, I draw one reference line at here first. Now I take the distance 10 mm and mark the point A dash. Okay, because point is 10 mm above HP. Okay, and here line makes an angle 45 with the horizontal plane. Okay, so this one is my vertical plane and this one is horizontal plane. Okay, so line makes an angle with horizontal plane, so we represent it on vertical plane because this angle seen in front view. Okay, so from here A dash point I take the angle theta is equal to 30 degree, theta is equal to 45 degree, and length is equal to true length, which is given 70 mm. So from here I take the distance 70 mm and angle is equal to 45. So here I get my point B. Okay, here I give the name B1 dash. Okay, because this is not my final front view. Okay, so here I give the name B1 dash. Here I at the end I find the final front view A dash B dash and final top view AB. Okay, but this is not my final front view, so I give the name B1 dash. Okay, now line is parallel to vertical plane. Okay, so here first I mark the point A. For that distance is given, point is 15 mm in front of VP. So from here I measure the distance 15 mm because point is 15 mm in front of VP and mark the point A. Okay, now here I draw the locus for point A. Okay, and from B1 dash I take its projection at here. So here I get my point B1. Okay, so this AB1 is my top view for this case. Okay, let's come to the second case. In this case line is makes an angle 30 degree with vertical plane. Okay, so first I mark the point A dash and A. Condition is same. Here I mark the point 10 mm above HP A dash and 15 mm in front of. So at here A. Okay, I draw the locus for A dash and A here. Now it's make an angle with VP, so we represent this angle on horizontal plane. Angle is 30 degree. So from here I measure the angle 30 degree and length is equal to true length 70 mm. Okay, so here I get the point B. Okay, now from B I take the projection up to the locus of A dash. So here I get point B2. Okay, here I give the name B2 because this is not my final top view. Okay, so I give the name B2. Okay, so here I get B2 dash. Okay, so A dash B2 dash is my front view for this case. Okay, now here line is makes an angle with both plane, horizontal and vertical plane. Okay, so now I just combine these two cases. Okay, so here I get the point A at 10 mm A dash and point A at here at a distance of 15 mm. Okay, this distance is 10 mm and A at 15 mm because point A is 10 mm above HP and 15 mm in front of it. Okay, now first I draw this case. So from A dash I take the angle is equal to 45 degree and length is equal to true length. This angle is equal to 45. So here I get the point B1 dash. Okay, and from B1 dash I just simply take its projection up to here. Okay, these are the locus of point A and this is the locus of point A dash. Okay, so I take the projection of B1 dash up to the locus of A. Okay, so here I get the point B1. Okay, now I draw this case. So from A point I measure the angle is equal to 30 degree and length is equal to true length. So at here I get the point B2. Okay, now from B2 I draw its projection at here. up to the project locus of A dash. So here I get the point B2 dash. Okay, so this one is AB1 is my top view length. Okay, top view length, and A dash B2 dash is my front view length. Okay, now draw the final line A dash B dash. Okay, I require to find the point B dash. Okay, here for B dash I have two conditions. Okay, here I draw the locus from B1 dash and locus from B2. Okay, so for getting the point B dash I have two conditions. Okay, point B dash is on this locus. Okay, this is the locus of B dash. Okay, so I get the point on this line, and second condition is distance between A dash and B dash is this much front view length. So for draw the line A dash B dash, I take A as a center. Take A as a center and radius is equal to A B2 dash. I draw one arc which intersect this locus at here. Okay, so here I get my final point B dash. So this one is my final front view A dash B dash. Okay, similarly here getting the final top view, I have two conditions to get the point B. One condition is we get the point B on this line and length is equal to A B1. Okay, so we take A as a center and A as a radius. I draw one arc at here which intersected here. So here I get my point B. Okay, so AB is my final top view. Okay, so in this way I find the final front view A dash B dash and final top view A B. Okay, in exam you not required to represent these two things. Okay, these two case I explain for your understanding. Okay, so you in exam just only represent this case. Okay, here front view makes an angle with HP is represented by angle alpha, which is apparent angle. Similarly, top view AB makes an angle with vertical plane, which is represented by angle beta. Okay, apparent angle beta. Okay, so for solving any problem of projection of line, first we require to find the four locus. Four locus means locus of point A dash, locus of B dash, locus of point A, and locus of B. Okay, and after getting four locus, I just simply from the true length draw the projection. From the true length I draw the projection. For example, here true length, from true length I draw the projection. Similarly here from true length I draw the projection. Okay, so from true length we always take the projection or draw the projection. Okay, and from front view length or top view length we draw the arc. Okay, here front view length, from front view length I draw the arc. Similarly here from top view length I draw the arc. Okay, so note down this point. Okay, so here I conclude this lecture. In next lecture we solve another 3 to 4 problem of projection of line. Thank you.